Hello everyone, and welcome to 7th grade Math Module 1, Ratios and Proportions. In this video, we're looking at Lesson 13, Finding Equivalent Ratios Given the Total Quantity. Our learning target is to use tables to find equivalent ratio of two partial quantities given a part-to-part ratio and the total of those quantities at mastery as measured by the proficiency scale. As we've been using this whole module, we're going to be referring to our fact family triangle or writing an algebraic equation in the form y equals k times x, where k, our unit rate or constant of proportionality, is the ratio in simplest form of y divided by x. In this exercise, we're looking at the table below, which shows 6 different sized pans that could be used to make macaroni and cheese. If the ratio of ingredients stays the same, how might the recipe be altered to account for the different sized pans? In order to solve this problem, which now has 3 columns in our table, we're only going to be able to focus on 2 columns at a time, and we can use our fact family triangle or an algebraic equation to help us solve. So first, let's focus on the 2 columns to the left with the noodles and cheese. That would be a part-to-part ratio because those are both parts of our whole pan of mac and cheese. So I chose to put cheese, C, in place of Y, and noodles, N, in place of X. There was no keyword in my problem, and I was not looking at independent or dependent variables. I just needed to choose which one would go in which spot so that I could find a unit rate, a K, of, in this case, it would be cups to noodles. I could instead do it the other way around, but for this example, I'm choosing this way. So I need to find a unit rate in order to be able to solve, and I do have a pair of numbers for noodles and cheese that are together, and that's the 3/4 cups of cheese to 3 cups of noodles. So keeping that order I chose of cheese over noodles, I can write that as a ratio, which makes a complex fraction. I can divide my numerator of 3/4 by my denominator of 3, and with keep change flip, that gets me a unit rate of a 1/4 cup of cheese per cup of noodles. I can now take this unit rate and put it into the equation C for cheese equals 1/4 N for noodles. So now that I have this algebra equation, or even just having this unit rate with my fact family triangle, I can solve for some missing values. First, I'm going to solve for the amount of noodles that go with a 1/4 cup of cheese. In fact, I want to zoom in so I don't even see that last column yet because I'm not going to pay attention to it yet. So to solve this, since I have a unit rate of K of 1/4 and a cheese value C of 1/4, I can use my equation replacing C for cheese with 1/4. So I get 1/4 equals 1/4 N. To isolate my variable, since I see multiplication, I'm going to divide both sides by that unit rate 1/4, which just leaves me with N noodles of 1. So 1 cup of noodles for every 1/4 cup of cheese. I could use this same strategy when I go to find the number of cups of cheese that go with 2/3 noodles. However, this time, since my cheese is what I am looking for, and I have my noodles, I am going to replace N in my equation with the 2/3. So then I would just do 1/4 times my 2/3, which gets me 1/6 cups of cheese when I simplify. Pause the video here and try to find the number of cups of cheese that would go with 5 1/3 cups of noodles. You can use an algebra strategy like me or pick your own. So to find the number of cups of cheese that go with 5 1/3 cups of noodles, I instead this time chose to use a proportional relationship and use my butterfly strategy to solve for my missing number. So for this, I just took one of my pairs of cheese and noodles. I took the 3/4 cups of cheese over the 3 cups of noodles, and I set it equal to a fraction with C for my missing cups of cheese over the 5 1/3 cups of noodles that I had. With cross multiplication, I do 5 1/3 times 3/4 and I get 4, and then 3 times c is 3c. Then to isolate my variable, I divide both sides by 3, and then c would be 4 divided by 3, which is 1 1/3. If I instead used my algebra strategy for this, I would have just done 1/4 times 5 1/3, and it would have gotten me right to that 1 1/3. So either of those strategies would still work. Now, I cannot finish the rest of my table here because there are no numbers for the remaining 2 sections of noodles and cheese, so my unit rate here is not much help. But when I zoom out and look at the table as a whole, I do see that both of those rows have a number of cups for the entire pan. Now, because my pan of mac and cheese is made up of just the noodles and the cheese, if I wanted to find the total cups for the entire pan size, all I need to do is add together my noodles and cheese. So for all 4 rows where we do have 2 pairs of numbers, I can just add those together to get my pan size. So for that first filled in row there, 3 plus 3/4 is 3 3/4. 1 plus 1/4 is 1 1/4. A little more complicated as we get to our next pairs of numbers. 2/3 plus 1/6 gets us 5/6, and 5 1/3 plus 1 1/3 gets us 6 2/3. So we filled in those pan sizes. We have all of our pan sizes, but we still don't have the noodles and cheese for the 5-cup pan and the 5 5/8 cup pan. In order to solve for this, we're going to need a new unit rate. And that unit rate is going to have to be made by looking at 2 of our columns. So this time, instead of using C and N as our Y and X, we're going to have to pick P for pan size to be one of those values. And then we'll have to choose to either just work with the noodles or just work with the cups. Then we can solve between those 2 columns, ignoring the third for this unit rate. I chose to use my whole pan, P, as my Y value, and my noodles as my N. Now, there wasn't any particular keyword or independent or dependent variable I was looking for here. I just chose how I was connecting this with my whole to part ratio. You could have instead done noodles to pan. You could have done cups to pan or pan to cups. You just needed to make sure you did the pan with one of the other 2. So for my choice of pan to noodles, to find my unit rate, my constant of proportionality, I would do the number of cups in the pan divided by the number of cups in the matching set of noodles. Now, the pair that I chose for this right here is this pair where I had 1 cup of noodles to 1 1/4 cups in the entire pan. And the reason I chose that one is because I didn't have to divide with 1 in my denominator. Remember, a unit rate is always going to have a denominator of 1. So in this case, when I do 1 1/4 over 1, my unit rate is just 1 1/4 cups. So my equation here would be that P, the whole pan in cups, equals 1 1/4 times the number of cups of noodles. So now that I have this new unit rate, I'm ignoring the other unit rate that was between noodles and cheese. I can use this to solve when I have one number out of my pair of pan and noodles. So to solve at the top, where I have 5 cups in my pan, all I need to do is place that in this equation. So 5 goes in for P equals 1 1/4 N. To get N by itself, I divide by this constant of proportionality, 1 1/4, and I isolate my variable to get that N is 4 cups of noodles. Pause the video here and see if you can find the number of cups of noodles that would go with a 5 5/8 size pan at the bottom of our table. So you can plug into our equation the 5 5/8 for P and divide just like I did before, but I am highlighting a different strategy yet again. Maybe you used our fact family triangle to solve. In this case, since we would be looking for n, our noodles, we would take our pan size in cups and divide it by our constant of proportionality. So 5 5/8 divided by 1/4 is 4 1/2. So again, there are multiple strategies that you can use. It is up to you which one you would like to use. Now that we've done this, there are only 2 spots left on our whole table. We could go through the effort of making a whole new unit rate for the pan and the cheese, but we actually already have a unit rate between the noodles and the cheese, so we can still use that original unit rate that we had on the left of our screen here to solve using our numbers of noodle cups to find our cheese cups. So you can pause the video here and see if you can calculate how many cups of cheese would go with 4 cups of noodles and how many cups of cheese would go with 4 1/2 cups of noodles using any strategy you like. So when I solved for my cups of cheese that went with 4 cups of noodles, I chose to use the algebra equation where I'm just doing 1/4 times my noodle number, which was 4, and I get 1 cup of cheese for every 4 cups of noodles. I used the same strategy down when I had 4 1/2 in for noodles. I just multiplied that by my unit rate of 1/4, and I got 1 1/8 cups of cheese for every 4 1/2 cups of noodles. The real trick with working with a table like this that has multiple columns is being flexible in our thinking. We can pick any 2 columns to be in this proportional relationship because all of these amounts are proportional. We just need to decide if at that moment we're focusing on a part-to-part ratio or a part-to-whole ratio. No matter which 2 columns you're choosing to work with, as you work through filling a multi-step table like this, there are 3 basic steps you are going to follow, which we did in this video. First, you're going to select 2 of the columns for your x and y values. Then, you are going to calculate the constant of proportionality for those 2 columns. Remember, it's always going to be whichever value you chose for y divided by the value you chose for x. Once you've done that, you can use an equation, a proportion, or a fact family triangle to solve for the missing number in one of those 2 columns if you have another number in the matching column. Now, if you've done that for the 2 columns you've chosen and you have more spaces on your table that you cannot fill, you will have to pick a new set of 2 columns where you have at least 1 pair of matching numbers and go through all these steps again to solve for any missing numbers in those columns. You may need to come up with multiple constants of proportionality, or you may need to go back and use a constant of proportionality more than once in order to complete a table like this. What does this video make you wonder about solving multi-step problems with tables for proportional relationships like these? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.